Good afternoon. A warm welcome to everyone at our live webinar today. My name is Jacek Nosal. I'm a co-founder of Neoncube, and I will be your host today. At Neoncube, we specialize in supporting various leaders from medtech and media tech sectors, working closely with AWS services. We value partnership over and long-term relationship over short-term contracts. I'm glad that you could join us at our live webinars today. Today's topic is scaling in the cloud, best practices for cost optimization and performance. The goal of this webinar is to share our knowledge and let you know key insights that we've learned along our journey. With me is my colleague, CTO of Radpoint, Michał Smoliński.
Hello.
I wanted to start today's session with like the very broad question. How does cloud solutions help businesses grow? And is the whole gist and idea worth it?
Mm-hmm. I think enable is the proper word to describe all of it. I consider cloud as just an enabler because cloud, the true cloud provider, allows us to instantly get access to whatever technology we need to implement our dream project. And we can start small, barely incurring any costs at all, and then basically sky is the limit. Once we figure out that offering of a top class cloud provider encompasses not just the virtual machine, but almost every almost every information technology available, including even quantum computing or satellite communications, then suddenly we are free to innovate without any barriers.
Okay, but we hear about these cloud solutions we've heard about them for many years. They grew with us, but does it suit every business? How do I know that I'm well suited to migrate to the cloud? How do I know that I should do that? Is it something that I should consider maybe first, or are there any precautions?
I think that the first thing that we should unpack here is what is cloud actually, because we see that there are many players in the market that's traditionally been offering hosting services or collocation of your IT equipment, or a mixture of both. And nowadays they advertise their services as the cloud. For me, they don't offer the cloud services. For me, cloud is a collection of many services at different layers of abstraction. So we have the very basic infrastructure as a service layer. We have platform as a service, and finally software as a service. So when you consider move to the cloud, either you think about lifting and shifting your existing workload to the cloud, or you think about starting a brand new project and deploying it to the cloud from day one. We always need to ask the question: what service actually do we need? Is it just a virtual compute? Is it storage? Is it networking? Is it security? Is it observability? Or a bit of both of all of these things? So the question is not that easy. We observe this working with our customers. There are basically two kinds of projects. The first one is lift and shift, where there is a legacy workload that needs to be, or is being considered, the move to the cloud. And there are obviously newer projects which are designed from day one to be deployed straight to the cloud. So in the latter case, it's obvious that the decision has been already made. But in the first case, different kinds of applications can benefit in a different scale from the move to the cloud. There are obvious advantages that show up always, like improved security, improved resiliency to certain threats, like, I don't know, denial of service attacks, or or improved reliability that stem from the simple fact that the services offered by cloud vendors are high quality, and they offer a guaranteed SLAs, which usually exceed what is possible within the typical on-prem deployments with the usually limited resources that individual projects can afford to support these on-prem infrastructures. So, yeah,
yes, SLAs not only on the traffic level per se, as availability level, but there seems that AWS has services that are, let's say, HIPAA compliant. In case of AWS Health Lake, for example, services that are GDPR compliant. So you not only get availability, but also in certain cases auditability as well.
Oh, yes. I mean, it doesn't apply only to AWS. It also applies to other leading cloud vendors. Our business is more and more regulated, and every day we see more and more regulations coming that we need to adhere to, and that's true. That achieving that compliance it's been increasingly difficult. Cloud helps us with that. As you mentioned, many services are already declared compliant with many legal or compliance frameworks, and that allows us to build solutions that have strong foundations, usually observability, auditability, data encryption, security services are like basic building blocks that need to be in place to let us innovate and basically think about maintaining and running business systems today. And
so let's assume that I decided to migrate to cloud. We mentioned that I'm getting security, like from the day, very first day. I'm getting auditability, so legal is happy because everything is compliant. I'm getting scalability because of the wide offer of the services that are designed for that particular law. What's the bottleneck here? Do I need to hire some new personnel? Do I need to shift like my paradigm and the general culture of engineers?
Mhm.
Because there is a cost here, right?
Yes, there's always a cost. There's not such a thing as a free lunch. The only question is what value we get for money we pay. And my approach to this is that, well, first of all, direct comparison of the costs. Let's take an example. You invested into a physical infrastructure on-prem. You're running a set of machines with virtualization layer on top of that, and you know that you are able to to run 100 virtual machines using that infrastructure. So you can calculate the cost of each of these virtual machines. And on the other hand, you take the pricing list of a cloud vendor. You calculate the cost of a comparable virtual machine. And you suddenly see that, hey, this is more expensive. The cloud is way more expensive, especially if you take into account the costs over a longer period of time. Because here on-prem, you just paid once, and that was your capital expenditure. Here in the cloud, you got operational expenditure, so you need to pay every month. Suddenly you say, hey, this is way more expensive. However, this is unfair comparison, in my opinion, because that comparison doesn't take into account the human cost, the cost of engineers that you need to hire anyway to support these infrastructures. The more the on-prem infrastructures, the more complex they get, suddenly you see that the more resources, the more people you need to hire just to maintain those. Here, in case of the cloud, that cost is already spread out among hundreds or thousands or hundreds of thousands of customers. So what you get is high quality machines where you just pay a fraction of the cost that you would spend on the engineers that were to support it if you stayed on-prem. So I think that first that's something that you need to take into account.
Okay, but we've all seen those builds in Cost Explorer. They tend to be very, very long. It's very difficult sometimes to, from on top of my head, tell what did I actually pay for, because the services are very complex here. Are there any advices to managing the costs, or maybe should we maybe incorporate the monitoring of the costs into like the general product journey when it comes to the market?
I think cost engineering is absolutely important. I mean, it's generally important in business, but in terms of cloud engineering is super vital, because cloud costs or infrastructure costs tend to exceed 20 or 30% of all fixed costs of every software as a service business. So that's a really significant cost that needs to be taken into account. Having said this, I think what helps is, first of all, the architectures have to be as simple as possible, so we can really be able to figure out what drives the cost. Devil's in the details. Many cloud services are cheap when you start using them, but as you grow, you suddenly see that certain numbers add up, and you should take that into account, how potential growth would influence your bill. You should take that into account at the beginning when you just design systems. That's why cloud native systems that were designed with cloud in mind are so much cheaper to run than a legacy systems that we basically try to lift and shift. Here, there's no cost advantage. Lifting and shifting legacy systems to the cloud gives us other advantages, not immediate ones. It opens up the path to cloud native, of course. It gives us immediate benefits in terms of security, availability, compliance, auditability, as you mentioned. But still, the very basic costs of the underlying infrastructure would not be caught. In terms of cloud native, we have much better control over what drives the cost. My personal experience is that I was always closely watching, sometimes even week by week, and sometimes even day by day, what is the source of costs, especially when the traffic is increasing. There are many detailed reports and multidimensional analytical charts that are usually available with every leading cloud vendor, so you can really understand what drives these costs, and to keep them reasonably low. There's just a couple of things you could do, and a couple of things that we always advise. First of all is to keep things simple. The simplest architecture tend to be the cheapest, and also usually they are the most reliable ones. Second thing is that over time we found that it's usually best to split your infrastructure into two parts. The part that you really take care of, usually that means is a part that stores your data, where the data persistency is required, when we have responsibility for maintaining the data. And this is something that we call pets. And there's other part of the infrastructure, we call it cattle. This is a part that we don't care about, in the sense that that part of infrastructure doesn't. It's predictable. It's predictable, but it doesn't store data. So we can easily, for example, kill these machines and launch new ones. That gives us flexibility, because we maintain and keep only a minimal set of services that are required to keep our data in place, to make sure that the data is stored in a durable way. And usually we tend to do this part of infrastructure using platform as a service offerings. They seem to be a bit more expensive than infrastructure as a service offerings, but offer the additional managed layer. So, for example, you could launch a Postgres database right on top a virtual machine in the cloud. It will be less costly, it will be cheaper.
Would that mean that I went cloud native just yet?
Not yet, but you could also launch the same database using platform as a service managed offering. It will be more expensive, but when you take into account the cost, for example, of maintaining, ensuring backups, data durability, point-in-time recovery, snapshot, disaster recovery scenarios, compliance with, I don't know, ISO 27K, and so on, business continuity management, you suddenly figure out, you come to a conclusion that, hey, that the platform as a service offering, its total cost of ownership is lower. So we try to keep a really, really small set or small subset of infrastructure built with platform as a service offerings that are initially a bit more expensive, but long-term are cheaper. And this is just the core, and everything else should be disposable. And we just ensure that whenever traffic is down, then we cut our resources. Whenever traffic goes up, we add more resources from the cattle category. And it works surprisingly well. And there's, of course, upfront engineering cost to set it up, to ensure that that dynamic infrastructure really follows your traffic patterns, that it really follows your usage patterns, so you can always provide enough compute power to support your customers or your users. But after really initial investment into that kind of dynamic infrastructure, when supported by infrastructure as a code, it provides for brilliant infrastructure that is really cost effective.
There is also one benefit about maintaining this infrastructure as a code. We get the processes like disaster recovery can get significantly easier. So going to the cloud with the let's say by the book way. So by maintaining software reliability engineers, maintaining infrastructure as a code, leveraging the services, not only using virtual machines, but using the tools that Cloud Provider does, allows you to have this disaster recovery process, which might be very beneficial for businesses that tend to operate with large amounts of money, because it seems that things happen, right? So it also gives you security in a way, and I'm not thinking about the security on like network or application level. I'm thinking about the business
continuity.
Continuity, and AWS has very nice tools in a way to allow you that. Tools like AWS CloudFormation that are like not only tools but also like core concepts in the cloud itself, right? What's easy sometimes it's double-edged sword, because it's very easy to get benefits, but it's also very easy to either screw something, sorry for the words, or to generate costs, because I don't know, one line and scaling database from the T4 instance to like super CPU computed or whatever the name is very easy, right?
Yes, and here's where the true cloud operator comes to play, because as you said, APIs and automation allows us to do marvelous things, but also enables mistakes. That's true. However, true cloud vendors offer us sets of policies which allow us to restrict what can be done using automation. So we can basically design certain constraints. We can build them in manually right into the very basic, deep into our, for example, AWS account or Google Cloud account. And these policies will enforce certain measures against uncontrolled rise of the costs. And I'm not talking only about the account limits, which, for example, prevent you from, I don't know, launching too many virtual machines. But it goes deeper. You can, for example, restrict from setting up machines in a different region, which could be non-compliant, for example, by doing just by mistake, or creating a reservation for a resource, also based in a separate region, which could be also costly. So there are measures that prevent abuse of the automation. That's the first thing. By the way, talking about costs, I forgot to mention the reservations, because usually with every cloud vendor, you can either have your resources available on demand, which is usually the most costly option, or you could commit to some kind of 1 year or 2 year or 3 year period and reserve certain resources which get much cheaper, or you can even bid on the open market for so-called spot market, where you basically buy spare infrastructure that's not used at huge discounts, leading even up to, I don't know, 90% of discount. So that's huge. Once you know how to do the dynamic infrastructure that scales up and down, you can utilize all these mechanisms to even drive the cost further. But my point is, getting back to the cloud infrastructure as a code, I think that this is a huge paradigm shift, because we no longer treat infrastructure as a capex, as our capital expenditure, as like our fixed assets. We treat infrastructure like a expendable, disposable, cheap things that we can basically have today and don't have at all tomorrow. It's a bit difficult to connect that to the requirements of certain compliance frameworks, like, for example, ISO 27K, which deals with security. It's possible. We've done this for several companies, and we have cloud companies that use exclusively cloud services that are ISO 27K compliant. It's not that different. I mean, it requires certain approach, but can be done. But yes, the critical part is to shift thinking. And this is where the role of site reliability engineer comes into play. And I think that that's also a big shift in thinking. Previously, we used to have system administrations, sysadmins, that basically were OpEx, so mostly operational cost, people who were maintaining various systems at various levels, starting from the infrastructure, operating systems, middleware like databases, search indexes, things like that, up to the application layer. Now we shift towards site reliability engineers, which usually are 50% CapEx and 50% OpEx, because these people, thanks to that automation, can develop things. They not only maintain systems, but they also use system programming to provide actually tools that can be used, for example, to ensure that even if we made a mistake and we, I don't know, launched some infrastructure that we don't need, and we can quickly get rid of that, or we can do the disaster recovery, as you mentioned. Once you have that culture that everything is code, everything is specified in the code, and there are no manual configurations done ever, both on the infrastructure as well as on the system level, but everything comes from the code, then suddenly disaster recovery is as simple as daily scaling up and down. And suddenly you realize that you've been doing disaster recovery every single day, scaling up in the morning and scaling back down in the afternoon when your traffic goes down. So suddenly we shift also the difficulty of things that were previously super difficult, and nobody really wanted to do that. And many companies never did disaster recovery. And some do it only just once per year, because that's required, for example, by the compliance frameworks, like mentioned ISO 27K. But suddenly, once you go cloud native, once you embrace the infrastructure as a code, suddenly you do it today, you do it tomorrow, you do it every day.
Because it becomes the part of the process.
Because it becomes the part of the process.
And a good example of that, which I wanted to discuss a little, is the project that we did for the media sector.
Oh, yes.
Which started small, because it started on a couple of virtual machines, but it makes for a point in this discussion because it came a very, very long journey. We've started on virtual machines, played a crucial role in scaling this to whatever the number was, and realizing that there might be some other benefits because of the costs. Then we decided to migrate it fully to the serverless infrastructure, leveraging then very new tool called, not nowadays, but then back then, AWS Lambda.
Mm-hmm.
Later, scratching our head because we reached some limits, and we had to have backup plans to deal with the traffic that cannot be served by these services, and ending up migrating fully to the infrastructure as a code, and doing, in our case, once in a year, disaster recovery. This project also leveraged the power of spot instances in a very, that's actually something interesting, because you've mentioned spot instances previously, and we talked about cost. And when you shift the paradigm to going fully cloud native, your business grows with that, and you learn. And you're learning every day because you have to. These tools are getting updated daily. Some specification changes in order to maintain. You have to adapt and grow with the platform. And I remember that we've used spot instances to do performance testing. So in order not to spawn like 200 virtual machines and pay X amount of money, we came into realization that we can do something like that, but for 20% of the money. And it's not something that can be read in the documentation. It's something that has to be a conclusion. A conclusion from the infrastructure that you own, from the business that grew with this application, and from the things you've learned. Sorry for this long monologue, and I wanted to point out one more thing that you are getting from the cloud vendor. You are also getting a partner, and not to sound cliche, but you are actually getting a partner because of how well the business support works. And what's your experience with that? Because from my experience, even because of auditability of the tools, it was surprisingly easy to find even the hardest issues and bottlenecks with the help of the vendor support. And it works surprisingly well. I was a little skeptic when I first started the conversation and raised tickets, but I'm getting impressed daily, to be honest.
Me too. I think that the most important thing here is that at the very basics, systems keep evolving. We see this every day, everywhere. Companies are innovating. Business requirements are changing. Scale is also keeps changing as the businesses grow. Their requirements, not only functional requirements, but also performance or capacity requirements changes, and we somehow need to support that. And as surprisingly as it is, still in many organizations, IT projects are managed in a way as if they were a building. That is, that you build a foundation, you do the design, do planning, you do trenches, create foundations, do scaffold, and build the construction and so on. And once it's done and inhabited, it's done. It's only maintained. And if thinking goes like this, if that's a mental model of in an organization, then every change that you want to implement becomes super difficult. And suddenly managing these changing requirements, ensuring that these requirements are met by the underlying infrastructure becomes devilishly complex for no apparent reason. Because if you embrace the simple fact that systems keep evolving, that your requirements will evolve, once you get used to this and embrace that evolution as a core principle, that you start small, when you accept this, that you need to start small, with the mind that you will never have the finalized design, that it will never be completed, and it will be mostly your OpEx that you will be carrying with you throughout the life cycle of the whole project or whole company, even, rather than it will be a typical capex that you invest once and then just have a revenue streams out of it. Once you understand this, then suddenly you learn, you become cloud native organization. Not only your system is cloud native, but your organization is cloud native, because suddenly you recognize your costs in a different way. Suddenly you take into account the indirect costs that you don't have to pay for. Like, for example, engineers that you don't have to employ, though you don't have to hire them to support significant part of your infrastructure of your services that underlie or power your business applications. And that thinking, that evolution and constant changes is actually a vital part of the business. Is something that is deeply buried in minds, people who support us at cloud providers. They live that principles every day. And it's true that we've been learning from them, and I'm pretty sure that they also learned a lot from us. Because we know that today we're solving simple problems. We have first customers, first users, it's small traffic, but it's small application. And every day we are faced with the problem of migrating this to a bigger and bigger infrastructures. And every time we encounter new bottlenecks in unexpected places, we need to scratch our heads, figure out how to overcome these bottlenecks. Every bottleneck is different. You can't read that in a book. So we need that support from the cloud vendors, and they've been there many times before, because other customers also had the same problems, and suddenly we have access not just to the technical support, but suddenly we have access to the talent and experience of people who are growing, hundreds
who learned on the problems of the very big players.
And
right?
although we have our unique problems, we had and we will have unique problems, but still many challenges that we faced and had to overcome becomes pretty typical at certain level of scale. So for me, it's always surprising that there are many people who talk about scalability and scale, but they never did that. They only talk about it, and they try to design their systems from ground up initially as if they were already like having millions of users. There are companies out there who design systems that have more microservices than users, which is ridiculous. We never did that, right?
Yeah.
I remember that when we
reacted. We didn't.
We always
reacted.
We've always been reacting to the challenges. It's difficult because usually you do this under the fire because you are on production. As users are showing up, there are more and more of them, and you need to be able to respond to that. That's why the high quality support services from cloud vendor are also indispensable. But I remember that when we started, we had super simple infrastructure, 4 or 5 EC2 instances, just virtual machines. We had a terminal multiplexer that allowed us to type commands.
Sysami who complained about this.
And we were able to type commands into 5 terminals at once.
That's
at the same time. And there was a lot of magic about how we did that. And that was something that supported the production workload initially. And over time, we were adding new services, but only when the previous set of services or previous architectural approach proved to reach its limits. That was the only guiding principle. And I think the biggest issue is always to change our minds, because technology is there to help us. And today, the technology is super friendly. You know what I mean? That there are, once you use it properly, there are tools that automate and help you actually do everything you want. Once you
I remember,
start using proper tools.
I remember the search box in Amazon Web Services that being that small, right? And it grows and grows, and they ended up putting the scroll there, giving sections, and it grows every day. So there are new things in the era of AI tools that are getting there. In their era of compliance, there are tools that are business specific, like we mentioned AWS Scaling, but there are tools for Internet of Things. So literally anything, if it's not there, I guess there will be at some point. So
That's true. I also think that, because you mentioned AI, and I think that changed a lot, because before the AI era, which is half a year ago or something like that, okay, let's say maybe 2 years ago, in my opinion, discussion or conversation regarding whether to use the cloud or not use the cloud were somehow justified. These discussions, I could understand that. I've been advocating cloud computing since, I don't know, 2018 or 2017, maybe earlier than that. But I understand that in many cases there was ongoing conversation whether it's worth to go to the cloud or not, or it's worth to invest or to change our systems, updates, and so on. However, now after we saw the Gen AI revolution, I think that discussion is irrelevant, to be honest, really, because the compute resources needed to run high quality models, or even lack of availability of open models that you could install and run from your on-premise infrastructure, basically means that we need to use these models as a software as a service or through the APIs.
Yeah, because creating this whole pipeline yourself would be maybe not impossible, but super time expensive, cost heavy, and you'd probably give up along the way.
Basically, you would be lost to the market.
Yeah.
Because today we can start scratch on an empty, I don't know, AWS account or Google account, and we can basically do marvelous things in 24 hours, just by employing a couple of simple services, writing a couple lines of code. Today, in new projects, we spend more time writing down prompts for Gen AI than real coding. And I'm not talking about vibe coding phenomenon. I'm just talking about the business value, how it is generated. Today, using, I don't know, 100 lines of code, you can generate so much business value when 80 lines of this code is actually a prompt, and 20 lines of code is just something that displays a form and a button.
Yeah, and it literally is research and development, not just solving development problems in order to get somewhere, but researching these tools, playing with them a little, learning capabilities. And
also, I think that plugging these existing API services, like for example, I don't know, hosted large language models, they are available. Some of them are available on-prem because you can just download open weights and run your models. Usually, this is pretty expensive because it requires that you redesign your infrastructure to spot many GPUs, which usually wasn't in the scope of typical investments in business. So it's basically easier to run these models off the cloud. Some of these models are available only in the cloud. You can't download them. But once that part of your application is in the cloud, it becomes so much easier to build the rest also in the cloud. Especially that there are many accompanying services. For example, I don't know, typical LLM requires some kind of guardrails. that prevents abuse of the model. And these guardrails are already provided as an additional cloud service, which can be used with every other LLM that is in the cloud offering. So somehow these services get interconnected. They work nicely together. They're tightly integrated. And if we insist of staying on-prem, then suddenly we need to develop so much infrastructure just serves the own purpose of a glue. Basically brings no business value. It's just a kind of glue that it's unreliable, that needs to be serviced, maintained, just to keep portion of your app on-prem and the rest, especially the most important part in the cloud. Once you figure this out, it becomes supernatural just to go to the cloud and stay there. Also, we see today that the border between training and inference on AI models is getting blurred. Some models offer fine-tuning. Some models offer RAG capabilities. You always, by looking how to generate the best possible value out of the interaction with AI models, LLMs especially, in many cases, we will be providing some additional training data and fine-tuning the model in real time, or just building additional databases for a retrieval augmented generation for RAG, which means that the line between inference and training becomes blurry. And again, once you do everything off the cloud, you have a broad portfolio of tools that allow you actually to do that fine-tuning, to do that additional training, to have fine-grained control over what the model can do. All the crazy schemes that allow one model to learn from the other, transfer learning, fine-tuning, all these technologies are available just using a couple clicks once you use the tools that you have.
And not only that, you also get something extra because they integrate well with already existing services.
And they enhance them.
Yeah,
and they enhance them in a nice way. Yes. That's why I think it's inevitable that we'll end up in the cloud completely. Not to mention the problems with, for example, procurement of GPUs. We all know that there are certain restrictions on how many GPUs, for example, we are able to buy. When we use cloud services, we have none of these restrictions.
And I wanted to thank you, Michał, for today's session.
Thank you.
It was very, very productive. Thank you for joining us today. If you are wondering about going cloud native, I advise you to contact us and appoint for a quick consultation. So have a great day. Thank you. And thanks again, Michał.
Thank you.